Assalamu alaikum guys, welcome. Okay, so now lecture 18. In the previous lecture we completed the trends in electronegativity and the concept of electronegativity, what it actually means. I told you that electronegativity is the relative ability of bonded atoms to attract the bonded pair of electrons towards themselves, okay, and it depends upon the atomic radius, it depends upon the nuclear charge, and both of them, when they are combined, the third factor which it depends upon is called charge density, and it directly depends upon the charge density. The greater the charge density, the greater the electronegativity. The lesser the charge density, the lesser the electronegativity. And the charge density by definition is actually the charge per unit volume, meaning charge density is also directly related to the charge, the nuclear charge, but is inversely related to the radius or to the volume of the atom. Okay, and then I gave you this trend of the periodic table, that the electronegativity as you go up the group and across the period and diagonally it increases, and fluorine being the most electronegative element and cesium being the least electronegative element, and the noble gases are excluded and the radioactive elements are also excluded. Okay, now not just nitrogen, not just fluorine, but in addition to fluorine, oxygen and nitrogen are also very electronegative, and they come after fluorine in electronegativity. Okay, electronegativity is actually measured in a scale called the Pauling's scale, but it's not very important though. Fluorine has the maximum value of 4.0. Okay, 4.0 is the maximum value of electronegativity, and all other elements, they have lesser than 4 values. Okay, for example, some might have a value of 3.8, some might have a value of 3.7 like these, and some might have values in 1s and 2s and stuff like that. So you don't actually need to know the Pauling scale. No one's gonna ask you the value for each electronegativity, okay, in your AS or A levels or anywhere in A levels, okay, but they will ask you a comparison between the electronegativities of different atoms, meaning which one is more electronegative, which one is less electronegative. For example, if they give you some element which is up here, let's say oxygen, fluorine, and this is chlorine, and then this is bromine, and then this is iodine. Now for example, if they want to compare iodine with fluorine, so how are you going to compare it? So, and for instance, if this question comes for 3 marks, so what are the 3 points that you have to write in that question? So basically, first of all, you are gonna say that iodine has a larger atomic radius as compared to fluorine, right? And if it has a larger atomic radius as compared to fluorine, then that means it will have a lesser charge density. A lesser charge density means iodine has a lesser electronegativity compared to fluorine. That's it. These are the 3 marks that you get. Okay, so I'm just gonna put them down over here. Iodine has larger radius, larger atomic radius. So if it has larger atomic radius, then it means it has a lesser charge density than fluorine, and if it has lesser charge density, that means it has lesser electronegativity than fluorine. Okay, this is how you explain stuff. Okay, for 3 marks, 3 points, simple as that. Now we are going to talk about the concept of bond polarity. Okay, polarity, polar actually means having 2 ends. Okay, for example, in our earth we've got 2 poles, the north pole and the south pole, right? North and south. So similarly, we've got 2 poles. Bonds that have 2 poles are called polar bonds. Okay, and bonds that do not have 2 poles, they are called non-polar bonds. How are these poles formed? Let's see. Okay, basically, first of all, if you've got 2 atoms of equal electronegativity, meaning if 2 atoms are there and they are identical, like the example I gave you earlier of chlorine. Okay, let me just make it a bit bigger. Okay, this is chlorine, and then there is another chlorine over here, and there's a bond in between them, and these are the electrons. I'm not drawing the other electrons, okay, the other lone pairs, okay, for simplicity. Now chlorine is identical to chlorine. This means their electronegativity is gonna be equal, and if their electronegativity is equal, then that means the pull from both the sides is cancelled out, right? And if the pulls from both the sides is cancelled out, that means the electrons are located exactly at the center of this bond, meaning it is midway from both the atoms. So that means if it is midway from both the atoms, then these electrons are not shifted towards any of these atoms. Such a bond in which the electrons are located at exactly the center of the bond is known as a non-polar bond. Non-polar bond. But now guys, if I were to explain you what a polar bond is, I will need two atoms which would have unequal electronegativities. For example, HCl, this is hydrogen, this is chlorine. Chlorine has a much greater electronegativity than hydrogen, as you can see on that periodic table. Chlorine is here, hydrogen is over there, and as you go across the pair, the electronegativity is rising. So chlorine's electronegativity is going to be higher than hydrogen, okay? And if its electronegativity is greater than hydrogen, then that means what was electronegativity? It was the relative ability for the bonded atoms to attract the pair of electrons towards itself. That means this nucleus of chlorine is going to pull this electron density more towards itself, and then the hydrogen, because of its stronger electronegativity, and these electrons will be shifted slightly towards the chlorine, okay? Now, this partial shift of electrons results in a very important phenomena. And what is that? Electrons are negatively charged and they have been partially transferred towards chlorine, but they have not been fully transferred to the chlorine atoms, right? This partial shift of the negative charges towards an atom, it induces a partial charge on that atom, okay? Meaning it becomes partially negative. Partial means this sign, this delta represents partial, okay? Partial. Okay, so a partial negative character or a partial negative charge has been induced on this chlorine, and these negative electrons have moved away from the hydrogen, right? Moving away from the hydrogen means that it has lost electrons, but partially, right? And what does loss of electrons do? It produces a positive charge. But did the electrons get transferred fully? No, they were partially transferred. So that means this hydrogen will get a partial positive charge. Okay, now such a bond in which two atoms of different electronegativities are bonded to one another, which results in the shifting of electron and the induction of partial charges on the bonded atoms, is known as polar bond. Okay, because it has two poles. Polar bond. It has a positive pole and a partial negative pole. Okay, so it's called a polar bond. So this was the concept of polarity. Bond polarity exists in a bond which is polar. And what is a polar bond? Bonds in which two atoms of unequal electronegativities have been bonded with one another. Okay, this is a polar bond. And two atoms which have equal electronegativities or close electronegativities, if they are bonded, they would result in a non-polar bond. Another classical example of non-polar compounds include hydrocarbons. Hydrocarbons. Okay, what are hydrocarbons, by the way? Hydrocarbons, as their name suggests, hydro means hydrogen, containing hydrogen, and carbon means containing carbon. Okay. So any compound that contains hydrogen and carbons only, okay, are hydrocarbons. No third element involved. These are the only two types involved in an element is an hydrocarbon. Now, hydrocarbons also fall in this category of being non-polar because hydrogen and carbons have somewhat equal electronegativities or very close electronegativities with one another. But if the electronegativity difference is huge like this bond, then it's gonna be a polar bond. Okay, and I told you it's called, and by the way, such a bond in which there are two poles, okay, only two poles, is also known as a dipole. Okay, so remember in the previous video I told you the concept of dipole will be also discussed. So this is what a dipole actually means. Di means two and pole means poles. So having two poles, a partial positive and a partial negative pole. Polar bond is also a dipole and it contains bond polarity. Simple and easy as that. Okay. So this was the entire concept of bond polarity. So by the end of this video, now you should know what actually polar bond is and what a non-polar bond is and what's the difference in between them. Okay, what's the concept of electronegativity and how is that applied on bond polarity. Okay, equal electronegativities, non-polar bond, unequal electronegativities, polar bond. Okay, unequal electronegativities, acha, slightly different electronegativities, still non-polar bonds. Okay, like hydrocarbons. Simple as that. And this pretty much sums up the discussion of this chapter. This video, not the chapter. We still have a lot of stuff left. So meet you in the next video then. Thank you.